All right, this is just a little more clarification on the limits and continuity FRQ from Tuesday. Some people requested a video. They thought it'd be a little more helpful, which is great. It means you guys are doing it to understand it, so that's super. So let's go look at part A. So this is actually quite a intense FRQ in that we've got 4 functions. We've got a graphical representation of F, a tabular representation of G, an analytic representation for H, and a piecewise representation for J. So that's a loaded stem of a problem right there. So just take it one piece at a time. For each of the values at -4, -2, and 0, determine whether or not J, so we're just going to focus on J here for part A, and we're going to break it into 2 pieces. Let's do at A equals -4 first. Determine whether or not J of X is continuous at -4. So the first thing we need to do is go figure out what piece -4 would fall on. It's entirely in F's domain. So really, when I'm looking to see whether J of X is continuous at -4, I'm really looking to see if F of X is continuous at 4. So let's go take a look at what we have here. Remember, for continuity, we've obviously got it defined at -4, but let's go have X approach -4 from the left or the right. Let's go -4 for J of X. That's going to be entirely the same as the limit as X is approaching -4 from the left of F of X. So F of X was the tabular representation. So I'm going to approach -4 from the left-hand side, and the limit's the Y value, and I'm sitting up there at 3. Okay? So then I'm going to take the limit as X approaches -4 from the right on the function J, which will be the limit as X approaches -4 from the right on F, because that's what piece we're in. -4 is in this piece of the domain. I'm going to go up there, come in from the right, and my Y value, or my limiting value, is 2. So in answer to part A, it's not scrolling for me, we are discontinuous at A equals -4 because the limit, you could either say the limit as X approaches -4 of J of X does not exist, or you could say the limit as we come in from the left is not equaling the limit as we come in from the right. So we have a discontinuity on J at -4. All right, good to go. Next up, just one piece at a time. I'm still on part A. I'm now going to see what happens at -2. All right, so where is -2? Also in this piece of the domain. So I'm going to take a limit as X approaches -2 from the left of J of X, which will be the limit as X approaches -2 from the left of F of X. As I come in from the left, I'm at 2. From the right and the left, I'm at 2. So the limit as X approaches -2 from the left of J of X is equal to the limit as X approaches -2 from the right of J of X. And it's equal to 2. But although the limits are equal, they're not equaling F of 2. Or J of 2, sorry. So really what I have here is J of -2 is equal to, what was it, 4, I think? Yeah, is equal to 4, which is not equaling the limit as X is approaching -2 from both directions because it was the same. Therefore, J is not continuous at A equals -2 or at X equals -2. All right? So that one had that defining value not equaling the limit. The previous one had the limit from the left not matching up with the limit from the right. So those are two violations of our three-part definition of continuity. And then for a equals 0, now 0 is on a boundary. So we have to make sure, first of all, are we defined at 0? And we are. We can see that g of 0 does exist. G of 0 is 2, right? So we could write that down. So that we're still in part A. When A is equal to 0, g of 0 equals 2, right? So j of 0 would exist, which implies j of 0 equals 2. Therefore, j of 0 exists. And some people lump this into another statement, but I like to think of it as three parts. Are we defined here? Yes. Now I'm going to take the limit as x approaches 0 from the left on j of x. When I approach 0 from the left-hand side, that's approaching f from the left-hand side of 0. So let's go up here and approach f from the left-hand side of 0, and my limit from the left is 2. Okay, let's do the limit as we approach from the right. That would be on g. As I approach from the right, tabularly, the limit is also 2. So let's say equals the limit as x approaches 0 from the right of j of x. Furthermore, the limit is equal to the defined value. So we would say, therefore, the function is j is continuous at 0 because, and you would say the limit as x approaches 0 from both directions on j is equal to j of 0, which is equal to 2. All right, that would have probably been worth a good, well, 3-4 points. I like it. All right, next up. So for part B, I like all of them. I like math. Math is cool. Right? You're probably like, no, yes, it's so cool. All right, letter B. For what value of k will j be continuous at 1? So let's go see where j is. That's at a boundary, right? 1 is where g, the table function, meets h, the analytic function. So I need to set them equal at 1. All right? So if I need to set them equal at 1, I've got to go to the table and approach 1. And I'm at 1. Okay, and I'm approaching from the left because it's from the 0 side. So let's write that down. The limit as x is approaching 1 from the left of j of x is actually going to be the limit as x approaches 1 from the left of g of x, which is equaling 1 according to the table. Well, that's got to be equal to the limit as x approaches 1 from the right of j of x, which will actually put me on h, the limit as x approaches 1 from the right of h of x, which equals, let's go up here, we have to go plug that in. We would have 1 ln1 plus k. And what does that have to equal? Well, let's see. That's just going to be equals k. And remember, that has to equal the limit as I come in from the left. So if the limit as I come in from the right is k, and as I come in from the left is 1, we'd say, therefore, k must equal 1. So part B is done. Let's do a little bit quicker erase here. Clear ink. All right, part C. Write an equation for each horizontal asymptote. Horizontal asymptotes are limits as we approach positive infinity on the function. So we're looking at f only, the graphical. And we also need to approach negative infinity on the function. Those would provide me with any horizontal asymptote. So let's head to positive infinity There's no horizontal asymptote over here. There's no graph even over there. As I approach negative infinity, though, I'm going to go like this. I'm going to hop it up. I'm going to come on up here. I'm going to hop on over here. And I'm riding on out to 3. So the limit as x approaches negative infinity on the function f is equal to 3. Therefore, y equals 3 is the only horizontal asymptote. That one wasn't very hard. Now we're going to take a limit as we approach positive infinity for j. All right, where's j? Here's j. I'm heading on out to infinity. That's going to put me on h everywhere past 1, so I'm heading on out on h. Let's go send h to infinity. So the limit as x approaches infinity of x ln x plus k, right? So what's going to happen to this as x goes to infinity? I will be going to infinity. The natural log also goes to infinity. So basically I'm going to have infinity times infinity, right? So that's going to equal infinity. I have an infinite limit. So when that's all said and done, is that the last part? What does it mean by interpret this limit? I'm not quite sure. So maybe it just means it's unbound or there's an asymptote there. I'm not quite sure what they want you to write. I don't have the key open. So let's do this. So remember, when our limit is at infinity, means it's unbound. So we could say therefore j of x is unbound as x goes to infinity, or we could say there's a vertical asymptote. I don't know, something like that, right? Anyway, you'd have to look at the key to see exactly how that was expressed. All right, I like it. So hopefully that's helpful. Let me know if it wasn't, and we can always do another one. Thank you for requesting it. By the way, this came from at least 3 of the first 20 people to fill in the Google form on this said it'd be helpful if you went over the FRQ so I can actually hear it instead of just looking at it. So I have no problem doing that. I have time. So anyway, you guys have a good one. Hope this was helpful. If not, let me know.